Every inspection in an aviation hangar relies on one primary diagnostic instrument, the technician's visual system. This diagram compares the processing bandwidth of our primary senses. The inner ear operates with about 50,000 nerve cells, while the human eye operates with over 1.2 million. This gives the eye roughly 24 times the sensory bandwidth of the ear. Because of this density, we rely heavily on sight for inspection. Treating the eye like a precision optical sensor, one with strict biological operating limits, is the first step in preventing maintenance errors. To understand those limits, we must see how the eye captures an image. Light enters through the cornea, which provides a fixed bend for 80% of the eye's focusing work. Behind it sits the iris, expanding or contracting the pupil to rapidly adjust light volume. Next, light passes through the lens, where tiny ciliary muscles physically change its shape, thickening for near objects, flattening for distant ones, a process called accommodation. Finally, light hits the retina, where central cone cells capture detail and color, while peripheral rod cells manage low light sensitivity. Producing a sharp diagnostic image relies entirely on this precise sequence of biological handoffs operating flawlessly. When the physical dimensions of the eye drift from their ideal shape, our baseline vision degrades. In farsightedness or hypermetropia, a shorter than normal eyeball causes incoming light to reach the retina before the image has fully converged, resulting in a blurry picture of close-up objects. Nearsightedness, or myopia, occurs when an elongated eyeball causes the image to converge in front of the retina. The resulting signal sent to the brain makes distant objects appear out of focus. Even with perfectly shaped eyes, time alters the system. Around age 35, the human lens naturally begins to lose its flexibility. This age-related stiffening is medically known as presbyopia. As the lens hardens, the ciliary muscles can no longer bend it enough to achieve near-vision accommodation. Fine print, safety wire holes, and close-up inspection targets gradually become a blur. Identifying these physical drifts is critical because they require AMTs to proactively adopt corrective lenses to restore their diagnostic accuracy. Genetic traits and environmental conditions introduce hazards that structural lenses cannot fix. For instance, a technician with defective color vision, daltonism, will struggle to distinguish red from green when identifying wiring or fluid types. This animation tracks the biological delay our eyes face when lighting conditions drop. If you move from a brilliantly lit hangar out to a dark apron at night, your central vision cones need about 7 minutes to adapt. Your low-light rods require up to 30 minutes to reach full sensitivity. During that adaptation period, visual strain increases. Poor background contrast, small object size, and relative motion all make it harder for the technician to distinguish edges and shapes in low light. Our bloodstream dictates how well these sensory cells function. Smoking cigarettes introduces carbon monoxide into the blood, blocking oxygen transport. This creates a dangerous state of hypoxia that rapidly degrades the sensitivity of the rods, compromising vision in dim conditions. Alcohol and standard medications act as central nervous system depressants. These substances degrade visual performance, focus speed, and awareness long after the initial ingestion. A technician's immediate environment and bloodstream can sabotage their inspection capabilities before they even look at an aircraft component. You can offset some environmental strain by increasing the illumination on your work area. However, the law of diminishing returns applies here. Excessive light creates reflective glare, which actively obscures fine details for the inspector. Mandatory safety protocols include wearing prescribed corrective lenses and ensuring that clear protective eyewear is used during all maintenance tasks to prevent foreign substances from entering the eye. Our brains often compensate for gradual visual decline, creating a false confidence that masks deterioration. Regular, professional exams are necessary to objectively detect these degradations before they impact safety. How do environmental factors currently affect your own visual inspections? Acknowledging and actively managing personal visual limitations is the ultimate safeguard against catastrophic maintenance errors.